brilliant. All right. I need a bit more width here. That'll do. There, Jürgen. Rigo, Arnold, Byron, Jose. Oh yeah, that's totally not useful. Yeah. Someone hasn't got all the values on those. I need a board view, damn it. That's okay. We can work out 99% of it. I think. Yeah. I'm gonna guess 99% of this stuff. It's gonna be fun. Lots of guessing. And if I'm wrong, I'll just have to do it again. But I'm pretty sure I'm gonna guess right. Hey Warren. So this is, yep, as you can tell, this is the new, sorry about this is really going to be a cluster job. The spout appears to have opened up a lot more than it should have, and I'm now putting down way too much paste, and I do mean that. Realistically, this is way too much paste, but it's going to result in some pretty sort of average looking results. Oh well. I don't think, oh maybe I've got some spare nozzles I can use. So we're going to do streak. This is how amateurs do it on YouTube. But I'm not an amateur today. I should be doing this professionally. I'm not going to wipe it off and start again. No way. Nope. What I'm going to do is just plow through. It's the proper, best way to do it. It shows your commitment. Yeah. So I was fairly sure I had some spare nozzles for these. Usually they come with a couple. No, could be wrong. It's more just the small components that's a problem. Because once we get onto these LEDs, they're not really an issue. Yeah, they'll take a pretty good random smattering of paste and keep on trucking. Because you don't really need a lot of paste. I mean, the proper way to do it would be to have a nice stencil. And I could have actually had one of them done up, but I figured, I'm still prototyping, so chances are if I get a stencil, it's actually going to, my superstition in me tells me that it will then ensure that this will not work properly. Alright, that's all the paste done. Flip's sake. Oh, that's right. I remember now. We have the bizarre blue coloured resistors for this one. Yeah, creature, it wasn't about the cost, it was about the superstition. Anyway, this will be just dandy fine. You can all, if you're gonna be all snarky and nasty, I'm gonna kick you right out. The other downside of a stencil, of course, is the fact that I would actually have to apply it and then use quite a bit of paste to ensure I get the proper coverage over such a large project. Hey, Micromage. Let's hope these holes line up. They do. Thank God for that. Creature, that's been dodgy when you do it that way. Hey there, JBV. Fortunately, you don't have to love me too much. Just enough to make you come back every now and then. But not too much. Got our LEDs. So I hope these are the right ones. I'll be really ticked off if these are not the right LEDs. 99% sure they're the right LEDs. 99% sure. Because unfortunately you can't really tell the difference between these and the other temperature rated one, yeah, the 4000 kelvins, just visually. There's no real distinguishing features. Naturally, of course, when I put these LEDs down, they all flipped over. I mean, you expect nothing more. And Mr. Tritz. Come on, turn around. The LEDs do not all go in the same direction. There's 4 different quadrants or 4 different segments, and they all have their own orientation, but I did try to make it as obvious as I could. So you got the arrows on both sides there, just to tell me that that is the way it's supposed to go. So if I mess it up, then yeah, that's really definitely going to be on me. You can see why I do not want to actually personally manufacture these. If I decide to put them into up for sale or something like that. I'm getting someone else to make them. Oh no, I've got leaded paste on there. Sadly, I think for up to a certain level of numbers, like maybe the first 100 or so, this is actually how they will be most likely assembled in a factory somewhere. There will be no pick and place machine, nothing like that. There'll just be some poor bastard who's earning 10 cents a day, and he's got to sit here and do all these LEDs and everything else manually. Because it actually takes a fair bit of work to set up pick and place. You've got to have all the right components in the right places, and you've got to make sure you've got a reasonably optimized assembly path. That's why I, in the end, never really ended up buying a pick and place machine, because it was like I just didn't do the numbers. Alright, now we need some, let's see, we need a 0 ohm 1206, and we need some 100 nanofarads and so on and so forth. Standard jelly bean stuff, that's what we need. Let's see, am I using 1206s for those? No, the 603s, damn it. Why'd I corner myself like that? Seriously, what have I done with all of my things? Well, the only thing I've got to be careful of is with the ceramics, like I can't use 16 volt ones there. I can use them here. What? These look almost like 805 size there. As in, it could handle 805. Oh yeah, easy peasy. Anyway, I'm just going to drop these jelly beans all over the place. Oh, for sure, an 8-year-old, any of these modern day kids would do a much better job. Faster too. Ooh, 25 volts, still a bit close. I was about to put some 25 volt ones down. I thought, no, you know what? Okay, that's got to be a 0 ohm resistor up there. That cap is probably going to go for a swim. So is that one. Right, we need another 0 ohm resistor. Where did I put you bastards? Because these are aluminium boards, you can't run traces on the other side. So any sort of jumpers or anything like that you want to do, it has to be done using 0 ohm stuff. Okay, so we've got to get some, say, I don't know, 50 volt rated caps for the other side. Because 25 is just a little bit too close, and so after that you basically go up to 50. Yeah, there is 35, but I don't know if I've got any 30. Oh, I probably have. Creature, this will go on hot plate, so there's going to be no control. Creature's now going, oh no, no, not the hot plate. And I'm just going, where'd that cap go? Now, fortunately, the the classic 7805s, they're quite stable, so even if I botch up the capacitance on the input a bit, it should still be okay. On the other hand, the LDOs lose their minds. Let's see. I'm sorry, I'm just trying to find an appropriate cap for what I want here. Yeah, these will do. This is a colossal overkill. This is a 2.2 microfarad, but it's 100 volts. But the fun upside is that it's a 1206 size. Yeah, that is one of the handy things of using the 603 pad size, is that you can go up and down a fair range. Like you can put an 805 on it, 1206 on it with most things. See, a 1206, it like shadows the entire pad, but at least it does fit. I kind of want it the other way around though. Yeah. That's more aesthetically pleasing. Not quite sure what to do about that. We need a 3-pin header there, but I'm not sure if it's going to actually remain stable or not. I suppose I could put it... No, you can't do that. I suppose I could put the long legs in, but it's probably not a good idea. Terrible, which makes it perfect. What I might do is just... You can slide the... So you can slide the plastic down a little bit. Somehow I think that's going to end up just... Yeah, we'll see. If it doesn't work, that's fine. We'll just do it again. Alright, let's get our heat plate. And somehow magically pick this up. Right, IEC cable. Gonna blow on it to make the magical effect. And we turn on the fume extractor. And we wait. Well, I don't know what's going to happen with the 3-pin. I'm kind of half and half. We'll see, won't we? I know it's a little bit overexposed, but I'm not adjusting the exposure. We're only up to 80 degrees now. 80, yeah, the edge has dropped. No. I wonder if I can put something under it. Yeah, I'm just gonna let it go. I don't care about the crookedness of them. Sorry. The nice thing about reflow is it will pull back into place most of the things. Okay, we're up to 150. We should start seeing shifting soon. Maybe, maybe not. There goes the fumes. Yeah, okay, one got pulled off to the side a bit much. We've got a tombstone. It's time to turn it off. I'm sure there's going to be some cleaning up for me to do. Like I said, this isn't really the most ideal way of doing reflows. Just got to wait for it to cool down. I can't take it off at this point because if I do, everything will just slide off. It's kind of cooked it a little bit. I thought it was going to be only up to 180, but it actually ran all the way up to 220. But you can see the coloration on here. It's gone a little bit yellow, so I mean it got a bit too cooked. Hopefully the LEDs aren't too affected. let's go wide again. The reason why the camera became overexposed is because I actually have it on a fixed exposure, and as it zoomed in with all the white, it kind of got a little bit overpowered. Just got to put all the parts back into the container. That's the power brick for it. These are the heat sinks, although I haven't drilled and tapped these ones, but I'm going to see how they go. The other thing I've got to work out is I've got these 120 degree separated holes around the Barlow ring. I'm trying to work out a way to actually affix them. It's around about 60 Celsius now, so I should be able to, yep. Cool. Actually, what I need to do first is flash them. Look, they sent me little thumbs up notepads. Maybe they felt like it was finally the right version. They're like, yep, this one's a winner. We're going to give you the thumbs up. If only I could believe that. Okay. Alright, that's good. I'm going to have to do some programming. I might just disconnect the USB-C. Ow, what's going on here? Right, let's shut it up finally. Okay. Yeah, it is cherry blue. I'm not the greatest fan of them, but they're a cheap alternative to genuine buckling spring. Not the greatest alternative, but still cheap. Personally, I would prefer genuine buckling spring, but I'm not that rich yet. Not anymore. Not for a new one. Okay, that should be programmed now. solves the... I love that the bastards didn't give me a... they didn't give me one of these cords with these power bricks. It's like, why? Why not? Okay, let us hope and pray that the polarity is correct on this. Would appear not. Oh, there I got a bridge. That's stupid, I didn't check for bridges. God, I'm an idiot. I'm tired, I'm sorry. Probably just ruined it all because, yay, frickin' bridge. Yeah, you know what, overall, that's a delightfully crap solder job. Alright, let's fix this up. There shouldn't be a major problem here because it's only bridging the outputs, so we're not like enduring a short to ground or anything like that. Oh, we're up to temperature? We're up to temperature. It hardly feels like we're up to temperature. It's just so difficult to get good heat into these things because of the aluminium. I pretty much am going to have to bring in the assistants. Ah, right, creature, so that makes that a no-buy, I'm guessing. Yuck, yuck. This is all very yuck, actually. Not very happy with this. I mean, yeah, flux helps, but the real problem here is that because of the aluminium, it basically turns your iron into... it just makes it difficult. Okay. So under normal circumstances that would just flow, yeah. But instead, because of the incredible thermal mass of the aluminium, it's like, nah, get stuffed, mate. You want me to do what? Not happening. Anyway, we're going to leave it chunky and nasty like that, because our main thing right now is to get it to work. Yeah, bub. Sorry? Yeah. It's probably one of the
I think those ones at the
come out of the ground, yeah.
I just thought I'd get you to double check.
Yeah, no, it's probably, where is it?
It's behind the door, back door.
Yep, it's one of those.
I thought it was, but I just wanted you to check.
Yeah, crap, where's my containers? I always forget to bring a container. I'll go grab one. I just remember there's a container in my office. They're cranky buggers too. Come on. Didn't see Taylor. Oh, no, okay. We've got a trapdoor spider here. Now, so if you don't like spiders, take a 5-minute walk or something, because you're not going to like this guy. These guys get pretty cranky. They get flushed out by the rain. They're little living quarters get flooded, and so they come out walking. And he's pretty cranky. In fact, he's probably, pretty pissed off. They will give you a hell of a bite. They're not lethal, but they will give you a hell of a bite. There you go. Okay, so what's really cool about these ones? Let's see, I'll find something that's not going to hurt him. I don't want to hurt him. Just clip off the end of it. Okay. See, you got these spurs on these front legs here. You see those spurs? That's pretty cool. They're used for grabbing onto things. So, and if you look at the toes, that's also a pretty good indicator of what they are. See, they've got two little, I don't know if you can see that. So you've got two little toes on the end of their legs. And very hairy legs. I probably should shave. We get a fair number of these. These are not funnel web spiders. Okay, but they can look quite similar, but they're not funnel web spiders as such, as in not the Sydney funnel web. Yeah, he's pretty angry. Let's see if he... He's got some... Can you just put your feet down, buddy? Have a look at your pedipalps. No? Jeez, scare the shit out of me then. It's a little scary when you're up close under a microscope. Anyway, I'm going to take him outside before he causes me any grief. I'll put my finger for scale. How's that sound? But I mean, you know, it's not that big. It's like barely an inch. They get quite a bit bigger. This is a young one. They get to about twice that size, and then at twice that size, they start to become quite intimidating. We're just going to get my torch so I can put him somewhere safe. Like I said, they just get flooded out of their homes, so it's understandable that they're not happy. Probably came in when the laundry door was open, you know, how we had everything open. So okie dokie, we're back. No thanks, JD. Spiders like that get to live a happy life around here. Okay, let's see what we've got going on here. First thing we need to check are our polarities correct. 24 volts, that's good. So what am I missing here? Nothing's going up in flames. Should be ground. Minus 2.4, what the flippity flip? 0.24. Hello, what's going on here? I'll be seriously miffed if that is actually the ground and not the pin, because I measured it before and that was the pin and not the ground. It's continuity mode. Okay, so there, so that's the pin I'm measuring. And then stick it down on the tongue on the floor. Yep. Okay, what have I done wrong here? Okay, so we've got a direct short somewhere going on here. Oh yeah, that's because duh. Okay, we don't have a short there. Okay, so that's good. I know the soldering's truly awful. You'll have to forgive me for that for the moment. Did I install that the wrong way around? That's the only thing I can think of off the top of my head. I think that might be backwards. That's the only thing I can really think of. Data sheet time. Let's see, what is this? Cat 4104. I'm going to say that's probably backwards. That would be my guess. No, pin 1 is with the LED returns. Interesting. I mean, I know that's shonky and everything. Interestingly, that programmed okay, so we can't have a rail short to ground. I mean, I know this looks really crappy, but I also know that I feel like it's more something going on with the regulator here. Even if one of the LEDs has bridged through or is backwards, it should still give us 24 volts, into the regulator. Mm. 24 volts in, 24 volts there. As I said, I don't expect them to be shorted at all. Alright, what we'll do is I will take one of those connectors for the DC jack, plug it in free, so it's just freely sitting there, and measure. Damn bugs are being annoying. I'm going to be really annoyed if this comes out. If this comes out negative 24, I'll be upset. What the hell? You only give me 24 volts, so why the hell I don't get 24 volts? Do you give me, I bet you they ship me, I bet you they have shipped me a 2. Yeah, that's what they've done. I ordered 2.1 and they've shipped me 2.5. That looks like a 2.5. Or is it? Yeah, that's probably a 2.5 barrel. Yeah. That's very annoying. Let's see if I can find it. Especially that there's no marking anywhere to indicate that it's one or the other. But yeah, that's what I'm guessing has happened here. They've sent me a 2.1, 5 rather than 2.1. Let's try the other one. Or they've mixed it up or something like that. I'm 99% sure I ordered. Yeah, you see that's a 2. I'm pretty sure that's a 2.1. Yeah, that's a 2.1. Where's the other one? Where'd I put the other one? Ah. They're actually pretty similar. That's it, 2.5 versus 2.1. There's not a lot of difference, but when you're not touching the sides, you're not touching the sides. I swear there's been plenty of times that I've gotten away with doing stuff like that though. So you use a 2.5 and a 2.1. What the far out? Have I been truly trolled? I bet you I know what's going on here. This is going to read This is going to read 24 now. I just know it. I just know it. No? Thank God for that. Should be negative 24. Yep. Oh, okay, there, I've got that one there. That one does nothing. That one there's got the voltage. What's the bit I didn't connect it? You stupid, you stupid idiot. Oh, I see what's happening now. Alright, what's happened here is that is not connected to that in terms of, that's just floating. That is actually the one that we need to go to ground, so we have to bridge that. Fuck me. Version 6 coming up. Oh, Jesus Christ. That is very annoying. And for that I will blame the yeah, I know what to blame. It's actually not myself this time. On the schematic, it did not distinguish between these two. And yeah, so that's why that's failed. Alright, this is gonna be fun. And by fun I mean annoying. I was very tempted to touch that just then. Now that effectively is a crowbar. But it's actually just a leg off a normal resistor or something like that. But at this scale it looks like a crowbar. It'll be 5.1. Yeah. Well, I mean, it was probably a good thing anyway. We had to get that bridge cleared off the controller, so it was a win. Here we go. Ah. Alright. I don't think the contacts are contacting properly. Yeah, see, they're a bit intermittent. Okay. They actually look pretty good there, but I guess we'll touch them up. Trouble is, a lot of these are close to being blind contacts. No, it's not the worst, but it's also not the greatest. So maybe there's an issue with my firmware. The trouble is trying to I'm trying to think whether I'll put a little bit of extra paste in there and stick it on the because if I hot air that, it's going to melt. think that middle one might be a problem. The switch doesn't need debouncing because the switch... oops, God, that's a heap. It's done in software. The debouncing is done in software, so I don't need any mechanical debounce, like, you know, resistor and capacitor for a low pass filter. None of that's required, thankfully. Awkward to try and get to the underside of it this way though. Totally orcs. And I'm probably going to burn my hand. Oh well, that should be interesting. Now, Mr. Daniels, your hand's going to burn before you get to that state. That's okay. I am going to use my famous don't melt shit technique. Might be easier for me to put this back on the hot plate. This does not want to melt. I think it's going to be a case of it needs a hot plate. Because I just can't get... I'll try a bit more air. It's not even making... You know what? Let's try this. Come on, heat up. Say thank you. Yeah, it's skew, no one cares. And that's pretty damn messy, but yeah, it's going to do the job nonetheless still. Just a bit worried about that particular leg. It seemed like it was drifting into the cold joint territory. And yeah, there's a lot of little dregs of solder paste, but we'll just clear that up. Flipping hot. It's like trying to handle a hot pocket. Hey there, Liam. Just wait for that to all cool down. So basically the light works, which is great. Yeah, for some reason the switch isn't quite behaving how it should. Now I don't know how sensitive those switches are. Some switches, like we found with that the USB capture keyboard things that I had, we found that they really do not like the heat. So I guess we'll see how we go with this. I mean, the bright going up works. Going down doesn't work. That's funny, when I actually push in, oh, I think I might have the pins reversed or something. That's yeah. Alright, I think what it is that I've programmed them slightly differently from when I did the bodge job the other day. So let's have a look at what my bodge job is and go from there. Okay, so other than the fact that it looks truly god awful, let's get some spit on there. Let's throw some spit down. There we go. Probably need a bit more. There we go. Bear in mind, I've probably now ruined the switch. Oh well. Yeah, it's feeling like that it's a programming issue, not a contact issue. Okay. So we've got crap on the tweezers, that's what we got. So we got pins 3, 4 and 5 are involved in this. And what we're going to do is we're just going to verify that it is switching according to how I believe it should be. And we do that by holding ground. Now the middle one should activate when I push it. Yep. This one should activate when I pull it. Yep. This one should activate when I push it. Yep. Okay. So the switch behaves as I expect. So now I've got to change the firmware to make sure it does as I expect. So let's try and remember this, everybody. Pin 3 is... What's pin 3 going to do for me? Pin 3 can be darken, so if I go that way it's darken. Pin 4 is on and off, and pin 5 is brighten. So let's bring up the firmware. Thank you, B-Blood. Much appreciated. Now, the other thing, of course, we need the tiny. We need the data sheet for the microcontroller, of course. Okay, so PA 7, 1, and 2. We don't need that anymore. I get the feeling that I've actually just used the wrong code. I'm pretty sure I've fixed this code before. Yeah, this is the wrong code, that's why. I know we did this code the other night when... And here it is. Yep. That's why it went all wrong. Because we used the completely wrong code. Okay. Okay. So it wasn't actually anything wrong per se, it was just me who was wrong. So program it. Not this stuff. When will I learn to put this into my bash RC? What? That did something funny to my program, my multimeter. USB naught. And RBY. Fantastic. Right. Now we might actually get the response that we were anticipating right from the start. Oh boy. Okay, so light on. Okay, that's full brightness, and it's letting me know by going blink, blink, blink. Okay, it shouldn't be dropping out like that though. Yeah, okay. Those two need to be swapped around. So, yeah, we've definitely got the right code, but now it needs to have them swapped around. I'm just going to go into quad mode, that way you can all watch what's going on. So what was pin 4? Okay, PA1. So PA1 and PA7 need to be swapped. So the easiest thing for me to do is up here. I think that should do it. Yep. Okay, now that I've got it set nice and dim, I should be able to pull the power. And when I plug it in, it should be dim still. Yep, that's good. Basically it means it's remembering the brightness state that I left it at. Yep. That might not have remembered because I didn't wait 3 seconds. Yeah, Christian, I am using the AVR EEPROM. Alright, next step. We've got to stick the heatsink on this. By the way, I did get another 5mm onto this, so yeah. Let's see how that goes. I'm just going to wash it down with alcohol. Just goes to show, even with an incremental change in your designs, it's so easy for everything to just not work properly. And that's why it can take so damned long to get prototypes out that, yeah, convert prototypes into products. Yeah, because the initial phase, you're just going along, you're trying to find out what will work, what won't work, and then after that, you're trying to actually, make it a viable product with minimal issues to the poor customers. Stick it about there. That should do it. Now, this actually isn't adhesive, this blue stuff, in the sense of it's not a glue or anything, but I found that once you apply it like this, it doesn't seem to come off, and what helps is that gravity is holding it down, literally. Hey, wood roach. Cool. Come here, wood roach. Come here. Come on. So, these are not cockroaches as such. These are wood roaches. These are very awesome little critters. Come here. So they've got a really nice mottled pattern about them. They don't hang around in filth like cockroaches. And he's flown off. Don't go into the light. Oh, Good job. He got into a spider's web and he got himself out. Okay. The power consumption on this, the maximum would be around about 12 watts. So it's 10 to 12 watts depending on what configuration you have and how bright you have it. So for the moment, even though I've got these little holes here, I haven't worked out how I'm going to use them yet. In fact, they're a little bit small. I think they're only 2mm holes, but if I wanted to make them any bigger, I start running into problems with routing the power around the ring. But I figure with a 2mm hole I might be able to do something. We'll just see, you know, some sort of grub cam or something like that. Yeah, it's a fairly good fit on that. It's a better fit than the previous one. Wow, I wonder if it'll take the 2.5. Let's see. It does. It takes the 2.5. Ah, the joy of... Okay, so this is minimal brightness. This is the old one. That explains that I had it upside down, right? Fair enough. Amongst other things. Okay, so that's minimal brightness. Let's see, let's go up to maximum brightness. I'm pretty happy with that. Yeah, that should be fine. If I adjust the resistor for the other 800 ohm resistor, if I change that, then that sort of sets the minimum or the maximum brightness it can go to. So if I really wanted to push it up just that little bit more, I could probably drop down to about 790 ohms or something around about that, and I will get just that bit more brightness. But the trouble is you start getting a lot of heat then, and I prefer not to. I mean, as it is with this, sort of around about there is where I like the brightness. What are you getting all upset about, Woodroach? Huh? What are you getting upset about? Huh? Oh, stop jumping on everything. Get out of here. As long as you don't land in my ear again. I think the problem that Woodroach is having at the moment is that I've got such bright lights in here, he really can't work out what's going on. Let's see, T3S works as a webcam directly in Windows, no specific driver necessary. Okay, so it's using the generic webcam system. Auto range is a bit wide. See, the trouble, what I want for each of those, the reason why I'm going to look at getting a lepton core and an interface board is because I need to, or I want to get the data directly rather than just having a pre-processed image. Alright, 1 o'clock in the morning, blimey heck. Anyway, so that's that's version 4. And now we've got version 5 that works quite nicely. Except for that damn one little thing. It's always got to be something, doesn't it? Anyway, so that's now version 5.1 that I'll have to do. But at least these will work. So maybe I can make a few of them up, and you know, some people might want them. Because the image that they give you will be already, it will already be compressed in the data, and it's going to be a JPEG image if you're lucky. If it was PNG images, I'd consider it, but I do really still prefer the raw data. Let's see, so I've got this many that I can... Because you don't know what data they're dropping out, and you don't necessarily know what the relationship between the consecutive data is, bits. I just prefer it if I can get it raw. That's all I'm saying. I just prefer it if I can get it raw and then let me generate the image, which is what I'm doing with the one that I've got now. I get the raw data out of the FLIR camera and then post-process it myself. Okay, so this one goes in here. It's interesting to see the variations that we've gone through. Actually, I don't know why I call that version 5, because it's only more like version 4. But yeah, I suppose this was the very first one, and we found we definitely needed more lights. And then we tried this one, we found we still needed more lights, and we needed need to go up to the 5000 Kelvin. And that was, and then this one here, which made Creature cry because the LEDs were all in a fixed alignment, and that still had to be powered by a constant current driver externally. And then, I sort of know why I'm calling it version 5. This one here was the first one that had the driver on it, but we just had the little push buttons on the side, and we didn't really find that to be effective. So then this version came along, which is the Bodge version with the rocker switch, and then now we've got the one that we're using right now. But yeah, it's very easy to go through a lot of prototypes. Okay, well, let's try fix something before I go to bed. See if I've got something that I'm allowed to fix on stream. Not everything I'm allowed to fix on stream. I have to record everything, but I can't necessarily put it on stream. What do we got here? Oh yeah, this one I can do. The other thing is, when it comes to infrared cameras, there's so little data. You could probably get a decent frame rate out of serial 115200. Okay, job. Thank you. I just need to clean up the top here. Anyway, so that's why I'm going to go with the lepton core most likely, because at least with the lepton core I can get direct access to everything, and I can make my own software to do my own analysis based on the sort of task that I'm performing. Prolux at the moment I'm using O-rings to just basically, you have the Barlow, the 48mm Barlow, and then obviously the light ring slides up onto the Barlow, and then I have an O-ring that comes in underneath it, and the friction of the O-ring against the Barlow itself stops the light from falling down. But I would like to find something that was more physically locking against the Barlow. It's pretty good now that I've reduced the diameter of the ring to be, it's only like a 0.5 millimeter play now. Before it was about 1.5 millimeters. Okay, so what have we got? 1706, does not start up, no lights or sign of life. One side USB port draws no power, the other side, okay, so probably got some sort of corrosion situation, I can only hope. There's no point booting it to try, we'll just open it up and have a look. Oh, notice the job data isn't on screen. That's because I didn't want old job data all over the microscope job. One idea I had is if I took those little 2mm holes, and if I say put a screw in there that has a grommet, and the grommet may be like 3 millimeters, so I'll then have like a 1 millimeter push from the inside of the ring against the Barlow, and that will probably tend to grip on more than what I'm getting right now. Hey Ed Boss, you watching Bluey? You mean Bluey the dog, girl Bluey? Could you get your PCB routed with spring tabs? Possibly, I don't know. But for now, I'm pretty happy with how it is. I just got to come up with that one last fix. Or maybe someone will 3D print something, a housing that will fit it. I just realised now that I have got this, I can actually switch it off. Because that was one thing that was annoying me, and why I ended up going with that three-way switch is because when I put the microscope out of the way, if it was going to be out of the way for a long time, I may as well just switch it off. Technically, it's still powered because it's not a physical disconnect. It's just simply not driving the LED driver anymore. So it probably has a quiescent current of around about 5 to 10 milliamps, I'd say. Pretty much whatever that 7805 regulator is going to be drawing. It'd be nice if it was lower, and yes, you could make it go lower. There are no shortage of tricks you can do, but I just don't see the point. Ah, your granddaughter's watching it, that makes sense. Wait, what are you doing that for, Paul? You don't need to take that one out. Sometimes you just accidentally keep taking screws out and you're like, whoops, wait, no, don't need to take that one out. So someone's been in this before. I can tell by the fact that the screw heads are chewed out, which means they've probably used a T4 or something. Was it T4? No, I mean a T5 on those. If you push down really hard, you can usually get them out with a T5, so I strongly discourage that behavior. Hey Andrew Hughes. So with these boards, I'm thinking this might be a 281 board. Anyway, they often get corrosion by the CD3215s, and it just takes out the power, and it's a good thing. And these are underfilled CD3215s, so they usually themselves are okay. You just got to clear the short. Fingers crossed that's what we're going to encounter tonight. Hey there, Jason. Did you just appear out of nowhere? So with the microscope light camera, I'm pretty happy with our light ring. I'm quite happy with that now. Like I said, just that one minor change to deal with the fact that I should have bridged those two pins together. And with that out of the way, it will be a pretty much a complete product. Although I suppose I may as well take the opportunity to work out how I can lock it against the Barlow. There is one issue that's going to come up, and that is if people don't have a Barlow on, then they're not going to have anything to grip onto. But almost everybody has a Barlow, and if they don't have a Barlow, they will have or they should have, just a protective filter in front of the primary lenses, or objectives rather. And if they don't, well, they're going to find out pretty quickly why they should. You really do need to protect the primary objectives of your microscope, because once they get dirty, you can clean them, but unless you've got the right gear, it's very hard to get them back to as good as they were originally. 3D printer holder, yeah, that's the other thing. I've got to get myself a 3D printer. Well, that's only like $800 extra now on my budget. And I'm going to say it's that one there. And it's a pretty classic for it to be this one over here. Oh, sorry, Jason. Okay, so obviously the light's off. Beep. Come on. Are you embarrassing me? Ah, there you go. I've got to get used to the amount of pressure I need. Ooh, maybe not this one. Yeah, with camera lenses, definitely also. I mean, okay, if it's just a cheap $150, $200 lens, no problem, but if it's some exotic lens that you spent a fair bit of money on, then you almost always want to get that protected with even if it's just a plain old UV filter or something. Alright, this thing's unfortunately going to make a liar out of me. Oh, it's a 923. Okay. Hey Florian, I'm first trying to work out what one to get. I'm thinking of the Creality Ender Pro S1 or something like that. It's about 800 Australian dollars. I know there's cheaper ones, and I know if you're already in the know and you've already got all the gear, then you can probably get away with cheaper than that, but this is going to be a blank slate starting point for me. I'm going to test the continuity on the CD3215s just as a on those caps, just in case. Ooh, my meter is errored on me. JCT, they are 5,000 Kelvin. It's I think they're 97 or 95 CRI. That's why they look nice. Okay, multimeter's up. I find the CRI is the big factor in a lot of this stuff. Okay, not shorted. Well, that's displeasing. How dare you not be signature failure? Okay, let's have a look at the other side. If it's not signature failure, it becomes terrifying. So the CPU, it shouldn't be the CPU because it's only affecting like one side, not the other, in terms of the CD3215 behaviors. Well, in this case then it's possible that one of the 3215s took a hit. Oh god, I can't believe I'm about to do this, but this is an unscheduled tool pullout. I had this sent to me as a sort of a thank you for me giving someone a copy of FlexBoard View. It's one of these. Basically, these are just simply glorified diode meters. That's all they are. In case people are like, whoa, what are these things? It's a glorified, well, it's a handy, useful, let's see, diode mode meter. And you just sort of plug in the flex accordingly. It just quickly goes along, checks all the diode modes of the pins relative to what it's expecting, and then it lets you, well, you just compare them. If you go, well, that doesn't look right, and then you can sort of suss out which CD3215 it might be. Okay. I don't know what these cost. I actually don't know exactly where to get them from, but yeah, they're around. So what you do is you pick the machine that you have, which is in this case 1706. And we've got the left hand side. Let's test. What? Okay, it's testing, and now I've got to try and compare the values and see if anything's really out of whack. That's the other problem is you have to use your estimations. Everything looks kind of about right there for me. So if you're a new person to this sort of stuff, then this probably can save you some time. I don't really buy these sort of things myself. Okay, so alright, so it has picked up something in this case. I'll show you what it looks like when it does that. Okay, so you can see here it's showing me pin 6 on this side is way down, so it's close to a short. You can also see the individual pixels. That's pretty damn cool, really. I love looking at it like that. You guys can't see squat. I wonder if I can have just enough brightness. Not too much. No, you can't see squat, I'm sorry. Anyway, it's basically saying pin 6 is way down low. Oh, and also, what else is down? 52 and 53. So was it 6, 52, 53? I'm just going to put it all back to its box, make sure I don't lose anything. There's also one for the display, so if you have display connector issues you can test it on that. So that's essentially what it is. It's a it has pre-programmed values in for the diode mode, and if it finds something that's drastically out, then it will squawk. So we've got those pin numbers. Now we can switch over to FlexBoard view and actually get the real update on what's going on there. Did everyone die, or is everyone still here? Everyone turned off as soon as I went commercial. What did I say this was, a 928 or a 239? I can't remember. N 923, yeah. Just nodding off. Good on you, Toltec. I'm fairly sure the 923 is basically yep. It's just a 239. There are differences, but for the most part we can consider them the same. Okay, so it's CPU side. And what have we got? Pin 6. And let's go into that one. So UB400 is being implicated by pin 6, 52, 53. Okay, it looks like the CC lines are being hit. That's probably the real problem. Yeah, that's great. So we've got both the CC lines are being hit, and oh, I should have just gone over here. That was easier. Okay. Brightness. At least we know it's on this side. Sometimes just knowing that alone is worth the investment itself. And so it is up here. That's going to be fun. That's going to be fun. Let's dig in a little deeper and see if we can spot anything that might be implicating on those CC lines. Otherwise, we'll just have to take out the chip. There is that resistor there that's looking a little bit corroded. This one here. I don't think that's got anything to do with CCs. No, that's not. Given that this is probably going to require the replacement of both of those, I am not going to do that tonight. I'm sorry. It's not that it's specifically a difficult task, but rather it's, yeah, we're right next to an AND here. So we do want to be careful. A little bit of corrosion there. Got to be careful of this here, not in general, by the way, if you're working on these boards. This is the Piccolo chip. It controls the power to the NANDs. So if you ever get the scenario where your everything seems to be okay except you're not getting a drive, then check around your Piccolo chip. Like I said, there's specks of corrosion, but I'm getting the feeling that this might have actually been hit by something. Someone had a bad quality charger or something. That's what my guess is, because I can't really see anything. Let's see if there's actually any of those diodes that are on that CC line. Although for both of them to be taken out, that's a little weird. Okay, DZB051. Okay, so these ones here, just those two there. We'll just check the continuity across them. Maybe they've shorted out. It'd certainly be an easier task than replacing the CD3215s. Yep. Okay, so that one there, it's got a 7.6, which is clearly wrong. So we're going to take this diode off and see what happens. Because sometimes, you know, the diodes actually do what they're supposed to do and protect the circuit. Damn it, where's my big chunk of metal that I used to stop things getting burnt to death? Awkward angle. I'll try that. Worst case scenario, if I cook them out, there's the chunk. It's not always the way it goes. You give up and then you find it. Yeah, it's not practical anyway. That's just a little bit too big. Too big to fit in there. Far out. I've lost the diode. Oh well. Yeah, let's check that resistance again and see what we got. If we can get the hairy bits off it. Boo! It's still down now. I'll just see if there's any others on that line. And that's a big fat no. Alright, so the diode was fine. It was worth a shot though. I'm just going to check the CC one as well. Interestingly, CC1's diode is on the other side. And it is, so we've got, what do we got? These two here. And just check what they read. It's probably going to beep. No? Okay. Well, it looks like whatever it is, it's predominantly on CC1. Oh, sorry, CC2, so anyway. Well, I guess tomorrow that means I will be taking, probably end up both of these chips have to come off, because usually when you do one, yeah, they're pretty close to each other. Like if I go to schematic, if you flip the board, you can see that they're basically directly above each other. So when you put enough heat to get that one off, you're going to upset the other one, so you do them both. And yeah, once you've done the set, then that should be all good. But that's probably going to be our situation. We'll get that fixed up, but we'll do that tomorrow. Alright, I'm out of here. It's been an interesting evening. Thanks for watching. I'll see you next time.